Hi everyone. If you notice, I kind of cut my video short on the last one because my dog decided to bark. And probably I have told you many stories by now about my dog. So we're going to carry on with the different types of reactions. And I've given you another equation here. So we have magnesium chlorate, and it reacts to form magnesium chloride and oxygen gas. First thing that you have to do is check to see if this equation is balanced. So let's look on each side. We have one magnesium. Remember, there's a parenthesis here and the 2 on the outside, which means the 2 applies to everything within the parentheses. So that means we have 2 chlorine and we have 6 oxygen. On this side, we have 1 magnesium, 2 chlorine, and 2 oxygen. So let us look at the way that we're going to balance this. Okay, so let's look at our magnesium. Is it balanced? We got 1, 1, great. Okay, 2 chlorine, 2 chlorine, looks good. Now, let's look at our oxygens. 6 and 2, not balanced. So what we're going to have to do is we're going to have to balance the oxygen. And that can be done by multiplying our oxygen on the right-hand side by 3. So we'll put a 3 here, which means that we would change this to 6 oxygen. Are we all balanced? Yes, we are. That was a simple balancing equation. So just by doing that, we have balanced our equation. So once we've done that, now let's look at the type of reaction that it is. We have magnesium chlorate going into magnesium chloride and oxygen. Hopefully this rings a bell and looks like something AB breaking down into A plus B. And that looks like a decomposition reaction. Okay, you have a compound AB breaking down into A plus B. So that is an example of a decomposition reaction. Let us look at another type. This is great because this gives us a little bit of practice with balancing the equations as well as determining what kind of equation it is. So let us look at this equation. Aluminum plus copper sulfate, giving us aluminum sulfate, and multiply that by 3, plus copper. Okay, so in this case, again, we have to look at balancing. So we have on the left-hand side 1 aluminum, we have 1 copper, we have 1 sulfur, and we have 4 oxygen. On the right-hand side, we have 2 aluminum, we have 3 sulfur, we have 12 oxygen, and we have 1 copper. So remember, leave oxygen until the end. Let us look at aluminum. Right away, we can tell that, actually, you know what? Let's work with sulfur, because sulfur has the higher number. Sulfur, we have 3. Here we have 1. So right away, that should make us think that we have to multiply copper sulfate by 3, changing this to 3 sulfur. So this goes. But remember, by putting the 3 here, we've now changed copper to 3 copper. And we've also changed oxygen to 12. Okay, so we've changed a lot of things by just putting the 3 there. Okay, so our copper is 3, sulfur is 3, so we have 3, 3. Oh, but let's look at copper. We got 1 copper here, now we have 3 copper here. So that means we have to put a 3 over here, and that changes the copper on the right-hand side to 3. So our sulfurs are now balanced, 3 and 3. Our copper is now balanced 3 and 3. Is our aluminum balanced? We have 2 and we have 1. So we have to put 2 before the aluminum here, and that would change this to 2 aluminum. Okay, so now our aluminums are balanced, our coppers are balanced, our sulfur is balanced, and look at that, our oxygen is balanced automatically. We don't even have to worry about our oxygen. Great, we have now balanced our equation. Now let's look at the type of reaction that this is. So we have aluminum and copper sulfate giving us aluminum sulfate and copper. In this case, so let me just erase this since we've already balanced our equation. It looks like we have the form of A plus BC, copper sulfate, to give us AC plus B. And I'm hoping that this rings a bell and it looks like a single displacement reaction. Okay? Now, what would happen if we had another type? Hopefully you now realize through the process of elimination which equation I'm going to be working with you. Now, let's look at the situation of sodium sulfide reacting with hydrogen bromide to give us sodium bromide and hydrogen sulfide. Okay. What do we do first? We balance. We have 2 sodium here, 1 sulfur, 1 hydrogen, 1 bromide, 1 sodium here, 1 bromide, 2 hydrogen here, 1 sulfur. Okay, so right away we can tell our sodium isn't balanced. We have 2 here, we have 1 here, so that means that we have to add a 2 before our sodium, which would change this to 2, but also change bromine to 2. Now our bromine isn't balanced, which means we have to put a 2 over here. And that changes the bromine to 2 and the hydrogen to 2. Going a little faster now with the balancing because hopefully we've got the hang of it by now. Okay, so let's look. 2 sodium, 2 sodium, 2 hydrogen, 2 hydrogen, 2 bromine, 2 bromine, 1 sulfur, 1 sulfur. We have a balanced equation. Now, what kind of equation is this? This looks like an AB plus BC, not BC, sorry, plus CD, giving you AD plus CB. Notice how the sulfur went to the hydrogen and the bromine went to the sodium. And that is an example of double displacement. So it's really good to remember these generic equations that I gave you that represent each of the different types of reactions. Once you know those, you can then link them to the actual equation that I give you, and you'd be able to determine what kind of reaction you are dealing with.